The central problem in clinical acid-base balance is to understand what factors determine the hydrogen ion concentration of plasma and other body fluids. We are dealing with aqueous solutions, that is, solutions where the constituents are dissolved in water. Thus, it makes sense to start by examining water and understanding its behavior. Each molecule of water has the chemical formula H2O, and pure water dissociates to a tiny degree into hydrogen ions, or H+, and hydroxyl ions, OH-. Because the degree of dissociation is so tiny, you may be surprised to know that the resistivity of pure water is extremely high. In other words, pure water is actually not a good conductor of electricity because it doesn't have many mobile ions, i.e. hydrogen and hydroxyl ions, to act as charge carriers when an electric field is applied. In reality, most water is a very good conductor of electricity, but that is due to many impurities that are dissolved in it. Peter Stewart formulated some basic definitions which are useful in the study of acid-base balance. He pointed out that the literature is replete with complex definitions and debate about the meaning of terms, but he felt that these few simple definitions facilitate an understanding, and so we're going to state them here. First, let's define neutral solution. When the hydrogen ion concentration is equal to the hydroxyl ion concentration in an aqueous solution, we consider the solution to be neutral. So that's our first definition. An acidic solution is one where the hydrogen ion concentration is greater than the hydroxyl ion concentration. A basic solution is where the hydrogen ion concentration is less than the hydroxyl ion concentration. An acid is a substance that has the effect of raising hydrogen ion concentration relative to hydroxyl ion concentration when added to a solution. And of course, a base is a substance that has the effect of raising the hydroxyl ion concentration relative to hydrogen ion concentration when added to a solution. A common measure of hydrogen ion concentration is termed pH. Let's first understand in simple terms what we mean by pH. pH is defined as the negative base 10 logarithm of the hydrogen ion concentration measured in moles per litre. Alternatively, this can be expressed as the positive base 10 logarithm of the inverse of hydrogen ion concentration. So if you remember your logarithm laws, you will recall that these two formulations are identical. Electrical neutrality is another definition which is key to the understanding of Stewart's model. The principle of electrical neutrality states that there is no net charge in solution. In other words, the concentration of positive charges, or cations, and negative charges, or anions, are always identical. For this reason, it is actually not possible to introduce a species like sodium alone into a solution. As a cation, sodium must be introduced with an accompanying anion such as hydroxyl, in the case of sodium hydroxide, or chloride, in the case of table salt. As you will see later in the course, there is a big difference between hydroxyl and chloride. Hydroxyl is a weak electrolyte and chloride is a strong electrolyte or strong ion. However, this will be dealt with in detail much later. The next important definition is conservation of mass. This is an obvious principle which we shall invoke frequently in this course. It states simply that no material disappears from the solution unless it is explicitly excreted. And of course, none is added to the solution unless it is explicitly added. In other words, it doesn't appear out of nowhere. The application of this principle will become obvious later in the course. I'm going to say very little about the concept of thermodynamic activities, but a few words may be relevant. There are a number of thermodynamic considerations which make it imperative to use the concept known as thermodynamic activity rather than concentration when describing solutions. However, in the dilute solutions we are dealing with in this course, this distinction is not as important as it is in other branches of chemistry. And for the purposes of this course, we will talk only in terms of concentration, and I'm not going to say anything more about this topic.